Here is the expression radical 5, which means the square root of 5. In this little video, we're going to begin to talk about what you can do with these things and how to work with them within a math problem. Now, you might be asking yourself, why do we care? Because the calculator will happily tell us that the value of the square root of 5 is 2.236, so why not just use that? The answer is that the square root of 5 is an irrational number, and 2.236, or however many decimal places you want to take it to, is only an approximation for the square root of 5, but it isn't perfect. The truth of the matter is that the square root of 5 times itself really is precisely 5, and that becomes an important distinction when you're working with it in the middle of a problem. When you use a decimal approximation, you can get close to 5, but you're not exactly on it. Let's take a look at the 4 basic arithmetic operations and see whether they do or don't work with radicals. First of all, multiplication. If multiplication works, then the square root of 4 times the square root of 9 should give us the square root of 36. Let's see whether that works. The square root of 4 is 2, and the square root of 9 is 3. When I multiply those, I get 6, which is the square root of 36. So multiplication appears to work just fine with radicals. Now let's try addition. If I add the square root of 25 and the square root of 4, it looks as though I should get the square root of 29. Let's see whether that's what happens. The square root of 25 is 5, and the square root of 4 is 2. 5 plus 2 equals 7, which is not the square root of 29. So addition does not work with radicals. Let's see what happens with subtraction. Let's look at the problem, the square root of 16 minus the square root of 9, and see whether that comes out to the square root of 7. The square root of 16 is 4, and the square root of 9 is 3, which equals 1, which is not the square root of 7. So subtraction also doesn't work with radicals. Lastly, let's take a look at division. Let's look at the square root of 100 divided by the square root of 25. If division works correctly, that should give us the square root of 4. Let's check it numerically. 10 divided by 5 equals 2. So that one comes out correctly. So to sum it up, you can multiply and divide radicals, but you cannot add or subtract them. Now let's see how we can use multiplication and division to simplify a radical expression. A radical is considered simple if the number inside the radical is the smallest one possible. So let's see if we can break down 20 into something smaller. The square root of 20 can be thought of as the square root of 4 times the square root of 5. And since the square root of 4 is a perfect square, we can call that 2 times the square root of 5, which is considered to be a simpler answer. Now that worked out really easily because 4 is a perfect square. But suppose when you first looked at the problem, you didn't think of 4 times 5. Suppose you thought of 2 times 10. There's nothing wrong with that, and we can still get where we're trying to go by breaking down the 10 into radical 2 times radical 5. Then we can group the 2's and end up with our same answer again. Let's try one more example just to make sure it's clear. Let's simplify the square root of 75. Again, it will be quicker if we can find a perfect square that goes into 75, so let's think about that. 1, 4, 9, 16, 25. Aha, 25. So let's break this down into the square root of 25 times the square root of 3. And then the square root of 25 can be written as 5, and we've succeeded.